1 second, okay? I'm going to have you a camera. Okay, hold on 1 second.
Okay, today we're going to be going over some weather basics. We're going to be reviewing the study guide that you should have completed yesterday. Let's start with air pressure. It's the weight of the air molecules pressing down on Earth. Remember, low pressure is lousy weather. You can remember low pressure, you have a low chance of getting out to recess. High pressure, you have a high chance of having recess because it's happy weather or good weather. Wind direction is just the direction the wind is blowing. Okay, so if it's blowing from the east, it's an easterly. And we know that the Coriolis effect makes the wind blow counterclockwise, such as in a hurricane or a tornado in the northern hemisphere. Temperature is just the measure of how hot or cold it is. Okay, so we could have warm, which we call tropical, or we could have cold, which we have polar, or we could have very cold, which we call Arctic. Humidity is just the amount of water vapor or moisture in the air. We know we have a lot more moisture coming in the maritime area because that's over water and less over continental. All right, let's move on and talk about some air masses and fronts. So exactly what is an air mass and how is it classified? An air mass is a large body of air with similar characteristics throughout. The two characteristics that are going to be similar are the temperature, hot, cold, or very cold, and moisture, either wet or dry. So how did they get their special characteristics, those two things, temperature and humidity? They get them by where they are formed, not where they are going. So make sure you understand. Look at the air mass. Where is it? Do not look at the arrows. It doesn't matter where it's going, only where it's coming from. All right, knowing that we classify by where it comes from, let's look at it. MP. M is maritime. That means it's going to be wet or moist. P means polar. That means it's going to be cold. Maritime, polar, moist, cold. Maritime tropical. Again, our maritime means it's going to be wet or moist. Our T tells us it's going to be tropical. Maritime tropical, moist and warm. Our CT is going to be continental. Okay, that means it's going to be dry. And tropical, that means it's going to be warm. So our continental tropical, it's going to be dry and warm. Okay, our CA. Our C, again, stands for continental, which is dry, and Arctic is the A, which means it's going to be very cold. So our continental Arctic is dry and very cold. Finally, our continental polar, dry for C, the continental, and polar is the P, which means it's going to be cold. So we have a continental polar, dry and cold. Okay, let's review about how we look at the air mass and how we decide what it is, where we name it. Okay, first of all, I need you to remember, blue is cold, red is hot. So blue, if they're blue, they're always going to be cold or very cold. If they're red or pink, that's going to indicate they're warm or hot. So using this picture, which air mass is formed over Canada? Number 1. Okay, so Canada is land, so it's continental, and Canada is also cold, so it's polar. So we would have a CP, continental polar. Okay, let's again use the picture. Which type of air mass would most impact Florida's climate? So we know Florida is down here at the bottom. Okay, it's surrounded by water, so we know that's going to be maritime. Okay, if we weren't sure what the latitude was, we can look again at the color. This is pink, so it's maritime, tropical. All right, now let's look at the air mass 4. It says, where is it forming? So let's go find 4. I see that here's Mexico and here's the United States. It is over land. Okay, if it's over land, it's going to be dry. And then it's in the pink. So it's going to be dry and warm. Dry and warm. And finally, it says, what temperature and humidity will we find at 6? So let's go up it to 6. First, let's figure out the temperature. It's blue, and it's way up here above Canada. And in fact, here's Alaska. So we know it's going to be cold. And it's over mostly water. All of this around it is water. So we have our maritime polar, cold and wet. Okay, let's talk fronts. Okay, a front is where two air masses meet. Okay, that's generally where weather is going to occur. So we have one kind of air mass, it might be a cold one, and then we have a warm tropical one. So we might have a CP and an MT. They come together and meet, and because they meet, some kind of weather is going to happen. So let's talk about our different kinds of fronts. First, we have a cold front, okay? As soon as you see the word cold, you know the cold air mass is the one that's in control here. It's the one that's really doing the moving and the pushing. So the cold air comes in, it pushes up under the warm air mass, and it forces that warm air to rise. It's going to bring severe weathers. That's where we're going to get our thunderstorms. We might get a tornado. We might get heavy rain, winds, hail. Okay, and then it's going to be followed by fair weather, probably cooled off a little bit. Okay, here we have a warm front. So again, our key word is warm. That means the warm air is the one that's moving. That's the one that's going to be taking over. We have our warm, moist air mass that just slides up and over the cold air mass. And remember I said it's just pulling on a warm blanket. It's just going to slide up and lay on top of it. We're going to have some gentle rain, maybe some snow if it's cold out. It's going to be followed by some warmer, milder weather. And finally, we have our stationary front. That's where a warm and a cold air mass meet, but neither really has the force to move each other. They sit there kind of in a standoff. You're going to have many days of clouds, precipitation, fog. A lot of times there's flooding with stationary fronts because it's raining for so long. All right, let's take a look at the fronts and what they would look like. Our cold front's our first one. You see the direction and movement of the front is moving from west to east. You can see the little triangles or icicles are also pointing east, so they're moving east. That cold is moving under the warm and it's pushing the warm air up. That warm air is headed straight up in an updraft. Okay. On the other hand, our warm front, the warm air is the one doing the moving. Okay, it's just slowly blanketing, like pulling up that blanket over the cold air. Okay, so instead of going up and creating an updraft toward the sky, it's going east. Okay, you can see it's going from the left to the right, and it's just kind of going over that cold. Stationary, they're coming together, but neither one of is moving. Finally, how would it look on a weather map? We said the cold front would look like these icicles. The warm front would look like semicircles or little half suns. And then the stationary front would be alternating both. It would have semicircles and icicles. All right, let's review some severe weather. Our three severe weathers were thunderstorm, hurricane, and tornado. How does it form? Thunderstorms form along a cold front. Remember, the warm air is forced to rise. Some thunderstorms have the really strong updrafts that begin rotating to actually form a tornado. What do they bring? Thunder, lightning, wind, hail, and heavy rain. We expect a warm air to mix with the cooler air, and we expect it to be a low pressure system. Remember, we said low pressure, lousy weather, and thunderstorms all night long are definitely lousy weather. Okay. Hurricanes. First of all, a hurricane has to always, forever until the end of time, need to form over warm ocean water. So we have our group of tropical storms or thunderstorms or disturbances, okay, that form. They're over the warm water. The warm water continues to get sucked up because the cold air is pushing it up. It starts spinning, and if it gets to a certain wind speed, it gets classified as a hurricane instead of a tropical storm. Remember, the eye wall is the most dangerous part of the hurricane, while the eye of the storm is the calmest. Our weather is strong winds, flooding, and the storm surge. Remembering that storm surge and the flooding is where most damage comes from. What will we expect? Some warm, moist air rapidly rising. Okay, it's going to be low pressure system, because remember, low pressure, lousy weather. And finally, our tornadoes. For a tornado to form, remember, first we have to have a thunderstorm over land. We have our thunderstorm. The updraft is next. That causes the air to start to spin more and more and faster. And finally, when it touches land, it becomes a tornado. Remember, if it never touches land, it's just a funnel cloud. The weather it'll bring is very strong winds that can pick up all kinds of things and take them somewhere else. It's highly destructive and it's fast. And remember, we have really low pressure there. All right, let's talk a little bit more about severe weather. When do we classify the spinning air in a thunderstorm as a tornado? Okay, so remember, all thunderstorms can have high winds, a lot of spinning wind, but we don't actually call it a tornado until it touches the ground. Remember, it's got to touch the ground. Okay, second, why doesn't a hurricane form over land? Well, because a hurricane needs warm, moist air to fuel it. Again, the fastest way to kill a hurricane is to put it over cold water or put it over land. What conditions are most likely to produce a hurricane? We need a low pressure, lousy weather over warm ocean water. And finally, this section. There are roughly 1,000 tornadoes each year in North America. This came right off your color by number. What part of North America do most tornadoes occur? In that tornado alley, which runs right up the middle of the U.S. Kansas, Nebraska, Oklahoma, part of Texas, that area. Okay, you're not going to get many in Alaska or West Virginia or Florida because it doesn't have the conditions. We don't have the cold air and the warm, moist air that we need. All right, and finally, what's the center of the hurricane called and what is its weather like? So our center of our hurricane is called the eye of the storm. That's where we're going to have the calm. Unlike the eye wall, which is the most devastating or the worst part. Okay, and what scales do we use to classify our severe weather and how are they classified? So our scale for our tornado is the Enhanced-Fujita scale, so it's EF 0 all the way to EF 5. And our scale for the hurricanes is the Saffir-Simpson scale, and they're both based on wind speed. Remember, we do name our hurricanes based on the alphabet. We do not name our tornadoes. If you have any more questions, either ask one of the teachers or ask one of your classmates. Hopefully that review will have helped and you will be ready for your test tomorrow.